Hey guys, welcome back to AlgoYogi, and today we will be inverting a binary tree. So let's go to our problem. I'm sure you already know how we need to invert a binary tree. There is not a lot of description here, but inverting a binary tree is basically assigning your left node to the right and your right node to the left. However, the trick here is you have to do it for each and every single node. Now, how do we do it? Really simple, to be honest. If you were solving it first time, you might not think it straightforward, but if you've already done it, I'm sure you have already written the. So in the example here, they have shown a binary tree before inverting it and after inverting, how it's going to look like. So this left subtree, after the inversion, they've moved it to the right side, right subtree. But also see, these children, they're also inverted. So this was right child earlier, now it's left, and this was left child earlier, and now it's right. So it's quite really simple. So let's basically see how we're going to approach this. So we can use any of the traversal technique that we have studied earlier, in order, pre-order, post-order, and that will let us visit each of the node. And while we are processing one node, then we're going to just simply assign the left to right and right to left using a temporary pointer. But then we also need to process the inverted tree as well, so that we are inverted to the last leaf node. So I think it's really simple. Let's just implement the solution. Let me change the view right here. If you can see, so let's write the recursive solution first, which is basically I'll be basically creating a inner function, calling it invert binary tree. Now that will be taking a root. I just like doing it this way. Seems cleaner to me. And this inner function is basically you call the inner function, it's solving your problem and basically returning the root. Now here we're going to have a base condition, so we can use any of the traversal. So we can use in order, post order, pre-order, whatever, but let's just not think which one we are using, because they're so simple, they'll come naturally to you while you're solving, while you're thinking that how you're inverting it, and then you're doing it for right or you're doing it for left. So if root is none, then we basically return. And now let's just process the root, so which will be in order, right? Or pre-order, sorry, processing the root first. So what do? We're going to have a temporary variable, and we're going to assign the left to it, and root.left will be root.right, and root.right will be root.left. What is root.left now? It's right now, so we saved it in our temporary variable. This is it. We have done the inversion. Now just let's call it on our left, which will be actually on the original tree, it will be right, but it doesn't matter, because once we are done with one side, it could be left or right. We come out of it and we process the next one. That will be right. Okay, and let's just call this function on root. Let me just focus here on the code if you're not seeing it clearly, and then we just return the root. Let's try to run it. I'll run it and see. Okay, and we can submit it. So it's accepted, but now let's talk about the time complexity. Pretty much in all the problems of binary tree, the time complexity will be big of n, and the reason is we are just visiting each node once. So this will be big of n, and then space complexity will also be big of n, given we're talking about that implicitly it's using the stack to place the subtrees on the or the root on the stack before it comes back and process it later. Keeps going until the last node. Wait, actually the space complexity is not going to be big of n. It will be big of h, because at max it will be placing whatever the maximum height of the tree is, going to the leaf node until if you're processing the left side, so it keep going down until the last leaf, and that will be the height of the tree, and then it comes back, it pops them off from the stack. So sorry about that, this will be big of h, which is height of the tree. Now okay, let's write the recursive iterative solution as well, and we know that we'll use stack, and let's just put our root that we will be processing here, and then we have while stack, then we want to process all the nodes on the stack. So let's take out the current node that we want to process from the stack.pop, and then we want to check if it's not none, then we will process it. And the process is simple. We are going to take the left node of the current node dot left, and then current node dot right will be current node dot left will be current node dot right. Cool. And then current node dot right will be temp. I think that sounds good. Now this is done, but we have processed the root, but we have left and right child also that we want to process. So let's just put them on our stack so that we come back later in our while loop and then process those. So current node dot left, and we'll do the same thing for current node dot right. Sounds good? I think sounds good to me. Okay, then we're done. We just returned the root. We're returning the root. Let's try to let's just see the code closely. This is how it's done, and let's zoom out and run it. We're having some issue. Awesome. Submit it. So most of the time, I think in later problems we'll be just writing the recursive solution, but if we know this is how you're going to process all the nodes, you can simply do it. Process left or right first, or process root, or right first and then left, or whatever way you want to do it. But then this is how you're going to do it. Honestly, the iterative solution also should be handy with you when you're solving it to the interviewer. Let's go to our AlgoYogi practice page and mark this done. Okay, see you in next problem. Bye bye.